Good morning once again. You're all welcome to another edition of Sambo's webinar. We are glad to have you all to join us once again.
Today's topic is all about integrating remote sensing, GIS, and big data for security monitoring. For security monitoring, this could be globally, this could be regionally, this could be based on nations like Nigeria, Ghana, or individual countries within Africa. The outline for our discussion today will follow this format. First, setting the scene, why security monitoring demands a geospatial lens. The second issue is remote sensing, spatial data, and analytical pipeline. Big data in security context. All this will be taken by me, after which the applied use cases will be carried out by Caleb. Then the tools for the platform and platforms will be carried out by Caleb. The practical sections will also be carried out by him. Then at the end of it, we'll have a question and answer section. Now, why are we concerned about security issue globally? Security is a fundamental aspect of any society. Whatever happens with the security of a nation affects the roots of that society. Hence, the need for radical check on security and monitoring of security. And security check has changed over the years. Maybe I will take us back to memory lane. After the beginning of industrialization and rapid development of countries, it set forth for the First World War, then second came the Second World War. It was at the Second World War that the information, the need for remote sensing for security management emanated from. There was a need for people to have a view of an environment, to know a detailed information about an environment. Apart from flying kites and apart from flying aeroplanes, taking air photographs, at that time, those were the major issues. So you have to fly a plane, take photographs of that location, come back, do what we call mosaic the imageries, understand the imagery, use telescope to understand the imageries, and to know where what is and where is a possible place of which the enemies are hiding or where you have to secure. Now, this was a very tedious task, and this continued till after the World War, up to 1950s. And at that time, research shifted from remote sensing, looking at aerial photographs and all those things, because there was a relative peace in the war. So security issues were not seriously centered around aerial photograph analysis. Then in the 70s, it came a rapid change with the development of the Landsat TM, Landsat satellite imageries, and that. When shuttles were being flown and information were gotten from shuttles, were gotten from satellite imageries. Then this data became so voluminous. So analyzing remote sensing data, satellite imagery become a tedious fact. And at that time, that was the beginning of the washing away of the use of aerial photograph. Emphasis were now on remote sensing imagery. 1, it covers wider area. 2, you can do it within a short period of time. 3, you can analyze and understand what you are doing. But you all understand at that time, the resolution were bad and the data were large. So there was a need for an instrument for the analysis of those data. And that gave birth to the rapid growth of GIS. Now, setting the scene, why security monitoring now demands geospatial approach. Just look at the war between Iran, Israel, Lebanon, and America. It is a war that is being fought using remote sensing and GIS. Any nation in the world today, if you want to fight insecurity, you must utilize remote sensing and GIS. No nation grows beyond its remote sensing and GIS. The growth in available spatial data has also increased in this period of 2020 to 2024. And at the same vein, security agencies citing data overload as challenges has also increased to up to 72%, because data management is beginning to become a very serious issue. So the challenge is no longer collecting the data. The challenge is managing the data. But we all know that we have passive remote sensing, we have active remote sensing, a situation of which you utilize majorly the active remote sensing you generate your energy to strike on the surface to get information from that object. It really is a signature based on the energy you send to the object of interest. That is active, then passive rely only on solar energy that is being sent, which I tried to mention initially before now, years before now, decades before now. Cloud and other environmental influence have been an effect when you are trying to carry out or extract data, satellite remote sense data using passive remote sensing. But there are super satellite imageries today that don't get affected by this cloud concentration that affects the energy of which is being received by object, then the signature is being read. Then let's look at what is GIS. We talked about GIS also earlier. You understand, we have mentioned some important part of GIS. It integrates hardware, software, and data to capture, manage, analyze, and display all forms of geographical referred information. Geographical referred information, it means that the data must have geospatial data. They must have spatial data model embedded in it. That is, they have location and they have references. They have better names, unlike the name of a place, but the latitude and longitude of that particular place. That gives that geographical value, that geographical information what a value. So when you look at this, you have a stored data. Within the GIS environment, we store data. What kind of data? Is store spatial data, holding layers of different features, like geographical features like routes, right? You have them being stored. Then you can also store attribute data within the GIS environment. Then you can query. The GIS environment help you to query. Ask spatial questions. You can ask which incident occur where. How does it occur? What is the area coverage? Where does it occur? What time does? You can ask such questions. Then it can explain details to you. Then analysis, you can overlay. You can do buffering. We can do cluster. We can do hotspot mapping. And we can also do network analysis within the GIS. We can also map, dashboard presentation, and also have the 3D scenes for decision makers. So the analysis are not important to any form until when it reaches the final users, which we call the decision makers. It's just like when we are teaching economics in those days. We say production is not yet complete until when it reaches the final consumer. So in this situation, the production, the analysis, the work of a GIS expert is useless until when the decision makers begin to use those values, those information, that is, those results that have been produced in decision making. The same thing applies in the security network. If you cannot use it for that, then it becomes an issue. Now, big data in security monitoring. So data comes in different volume these days. It comes not in those days when you have data in gigabyte. Today data comes of terabytes. Satellite imagery comes in terabytes. Millions of sensors. Things are everywhere. Social media streams, call records, transaction data, all are generated continuously. As we are talking, data are being generated. And they are coming in large volume, in terabytes. So this becomes an issue that needs to be addressed. The velocity, the real-time data streaming, the way data come real-time. From IoT sensors, from CCTV networks, from OSINT feeds, and emergency dispatch system demanding near instant precision. Now, last 2-3 weeks I was in China, went for a program. Virtually everywhere you have CCTV, apart from the toilet. But even camera leading to the toilet, there are cameras everywhere, even with inside forest, so that you can cut down a tree without anybody seeing you, because of the high level of precision of what they want. So data come continuously in larger countries. And remember, China is bigger than the whole of Africa. Therefore, you should imagine the kind of data of which you are getting. In Nigeria, though we don't have a lot of CCTV, we don't have a lot of this and all that. That simply means it's a market for GIS geospatial industries in Nigeria to begin to do it. For example, you can manage for each country, each state, each local government when it comes to the issue of insecurity. Then we have variety. The data come in different form. Some come in form of that. They are in different form of database. Some are unstructured, like text messages. Some come as images. Some come as videos. Some come semi-structured, like JSON feeds. All needing fusions into coherent, intelligent picture. You have to fusion them, you have to look at them, you have to mix them, you have to understand them. You have to make them in such a way that the information can be related to the users. So the key security data sources are the satellite. First, we have the satellite and aerial imageries. Then we have the CCTV, surveillance feeds. Then we have the social media. We have the mobile IoT sensors. We have the incident crime bases. Then we have the border crossing records. You will observe that in so many African countries, we don't have information of border crossing records because we don't have cameras. We don't have satellites that monitor the movement of people, animals, and also materials into the country, like in Nigeria. Our border is so large towards the north that monitoring it is a disaster. Then the integration framework. How do we integrate this data? We have them into 4 spaces, of which we just have to intervene. One is a collection of data. To collect the data, this can be done majorly through the satellite imagery, the sensor feeds. You can get the data through that format. What kind of satellite do we have? If you check the developed nations of the world, Nigeria inclusive, our satellites have all sensing facilities at poor. How many shuttles do we have? How many space remote sense shuttle do we have on space in Nigeria? How many do they have in Ghana? How many do they have in Niger? How many do they have in Chad? How many do they have in Cameroon? What is the quality of the satellite we have on space? What are their resolution? What are their capacity? What are the kind of data? Got it. What is their return period? So the first stage is having good satellite imageries. Then the second stage is integration. Data fusion. Attribute data and spatial data. Integrating this to make sense out of it to fight insecurity. Standardization of this data, organizing this data in such a way that can be understood and can be used in security management. So then the next stage is analysis, spatial analysis of this data. Pattern detection. This can be done using machine learning in recent time, and you can also do that using AI models to predict and to understand and to make policies and to also fight against insecurity, to mitigate insecurity, to nip it before it occurs. So the analysis follow that format. Then the next stage is visualize. You visualize, you produce output in form of maps, real-time output. This map can be changed simultaneously. It can be monitored. It can be done for states. For example, if a contract is given to Samples, for example, to manage, let's say, Kaduna State, you meet the governor of Kaduna State. Oh, this is the area. You map out the boundary. Automatically, you have collected data. Then you say, okay, these are the nature of forest. These are the nature of crime in those parts. You are integrating this data. You are managing this data. This is the area where these are the flashpoints of insecurity. These are where we have the mountains. These are where we have the islands. Those are the possible places for hideouts. You integrate it. Then you analyze the whole data. Then you visualize. You begin to say, okay, those are the hotspots. Then you center your analysis around those areas. So whenever somebody is kidnapped, whenever there is banditry, you will know where the culprit will be heading into. You can trace. And again, we are not talking about tracing them. We are talking about monitoring them before even nipping them, getting them before they get into the act. So we can map out those things. Then we can set out alerts, then bring out reports. That is the fourth stage. You after when visualize it. Then you will know where you have your security posts. You know where you send more foot on the ground. You know where you put more CCTVs. Then you know how to monitor the environment. Then you know where you have your situation rooms, because there'll be consistent situation report. And I don't think there's a state in Nigeria that does that. And it's a very simple task. A contract can be given to a geospatial firm like somebody's now to manage some of those things. They can do that. Manage this for us. Then monitoring the data, the way the data move, the information, the crime in relation with the environment. In this case, you are looking at risks, looking at exposure, looking at sensitivity, and looking at possibility of a crime based on the data of which you have on ground. Then the last stage is decision, which is to decide. You combine decision by maybe a state governor, the president of a nation. Then you know how to dispatch resources. This resource is not only money. It can be drone. It could be human resources. It can also be technical resources. You will know where to settle it. You will know where to set up police stations. You know where to set up military barracks. You know where to set up checkpoints. You will know which forest you should monitor. You will know which forest to be monitored. For example, you have good satellites, and there are issues of kidnapping. Already you have in your database that these are the possible places where the kidnappers will stay. Anywhere you sense smoke, or you sense that the temperature is higher than the immediate environment, oh, there is a flashpoint. When you do LST, you know, oh, this place the temperature is high, something is wrong there. Or this place is unnecessarily hot, you want to keep. Right? You need to keep, there are people living there. Then with that, you can now make your decisions. So those are processes of which we can use in decision making and addressing the issue of insecurity.